Okay, everybody, here's a good idea someone gave me. Go ahead and let's just do some problems then. Here is the first question from your Chapter 7 test review. I'm just going to go through these in 15-minute blocks and upload them in parts, and I'll just put the title of, in the title how many question numbers I got through. Okay, so here's number 1. Suppose the probability of A happening is half, probability of B happening is 0.3, and the probability that they both happen together, their intersection, is 0.2. Find the probability that either one of them happens. Well, you could think of this as a Venn diagram. I think the Venn diagrams in this section are very helpful. Let's call this A, let's call this B, and we want to find the probability of either one. Probability of A and B, that is what we would call the intersection. This is the, remember this means intersection, and that's kind of like saying and. Follow me, pen, come on. It's like saying and. It's when both things have to happen together. It's like you have to have a diamond and a four, and this one of course is or. It's like union. In the general Venn diagram sort of sense, you can think of the intersection would be this. We would sort of have, the thing that usually has this shape, and the union is the thing that generally has this shape. It's everything all together, whereas the intersection is just the part between. So this little piece here is just the stuff that's in here. So I have a 0.2 chance of falling in there. Remember, I have a 0.5 chance of falling anywhere here in A. So this entire circle for A has to add up to 0.5. So I have to do this. Now, A is 0.5. B has to have a total of 0.3, including this 0.2. So now if you look at that, B here total is 0.3. A here total is 0.5. I've basically translated all this stuff now into here. The question was, what's the probability I'm going to land anywhere in here? What's the probability that I'm going to land in any of this entire zone? And now these little regions are separate places. This is the stuff that's in A that's not in B. This is the stuff that's in B that's not in A. And this is the stuff that's in both in order to make the correct totals. Altogether, this adds up to, and I can add that because it's separate stuff, adds to 0.6. So the chances of something falling under A or B is actually 60%. Okay. All right, on to number 2. Assuming that each one of these spinners is fair, how many outcomes are there in the sample space of the result of spinning both spinners? This is sort of like dice. I have spinner 1 and spinner 2. And how many ways are there for the first spinner to turn out? You can think about that. And how many ways are there for the second spinner to turn out? And this is kind of like dice. We have with dice we have 6 opportunities, 6 outcomes for the first one, and 6 outcomes for the second one. And if you list them all, you get 36. If I list these all, I could list, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 2, and those are all different. So 5 choices for the first, 5 choices for the second. That comes up to a total of 25 possibilities. What is the probability that? Well, before I even read any further, I know it's going to be out of 25 because that's a sample space. So this is like saying now, to fill in this numerator, how many of those 25 has a sum of the 2 spinners larger than 7? Well, we kind of have to think about this a bit. How many ways do they have a sum larger than 7? Well, if you think about the array, kind of like you were having dice, first spinner, second spinner, you could show this picture of, okay, I didn't really have to put a dot, there's only one thing missing there. 2, 1, 3, 1, 4, 1. And think about where the sums down to sort of 5, 5 in here, and there's this 5 by 5 picture of all those possibilities. Where are the sums that are larger than 7? You know what? Maybe I need to fill all this in. Give me a second. I'll save some time. And bam, just like that, magic wand, it's all done. You didn't need to see all that and waste all that time. So here would be the array of all of the possibilities of the entire 25. Which one of those have sums higher than 7? Well, it says larger than, so I can't count 7. That's higher than 7, that's higher than 7, that would be the sum of 9, here's the sum of 8, and I think I'm done. All these now are going to be 7 or less. These are going to live along diagonals because I made this nice systematic array of numbers here. So I just count that up, there's only 6. 6 out of 25 are bigger than 7. Do you have to make this entire array to know that? No. You could look at this, and if you're good at counting and you're very careful, you could, I guess I would start at the top and come down. The biggest sum you can have is 10. There's one way to have a 10, and then 9. I mean, basically, I'd be trying to talk my way through finding these possibilities without seeing them all. This did take a bit of time, but it's rather safe. And then once you have this, if they ask a whole bunch of different probability questions, it's real nice to be able to see and pick and count. for those types of questions. All right, so just like for the last one, I went ahead and pulled up the array for the tossing of 2 dice, which is the same thing as tossing the same one twice. First toss is white, second toss is pink, according to this one. What's the probability that... Okay, wait, stop right there. What is the probability that... My answer is going to look like this. Okay, what is the probability that the first toss is smaller than the second toss? Well, that does not count doubles. They're the first toss and the second toss are the same. I need the first one to be smaller. Here's where they're equal. If you look carefully, then it's the ones on the upper part of this. So all of these in this sort of triangle. These are going to be the ones that are... well, the first one is smaller than the second one. If you look carefully, that's what that is. How many are in there? 5 plus 4 plus 3 plus 2 plus 1. That's 10. Sorry, that's 15. I forgot about the 5. And you know, I like to reduce my fractions because I don't want to get laughed at. So there we go. Okay, 5 out of 12 is the answer to that one. Okay, these next couple I figured I could get on one page. I made this really large because it fits. 7 factorial and 10 factorial are pretty much the same. The only difference here is, if you think about this, this is 10 times 9 times 8 times 7 times 6 times blah 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 times 2 times 1. The denominator of this is, I'm going to write it right under here, you're going to see why. 7 times 6 times blah blah blah, the same blah 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 as that, times 2 times 1. All of this stuff is the same, top and bottom. We've done this a lot. That and that divide each other to death, and they're gone. They equal 1. So really all I have here is 10 times 9 times 8. The sort of difference in a multiplication division sense of 10 factorial and 7 factorial is just the stuff that's left over beyond 7 that gets us to 10. And 10 times 9 times 8, I can do that in my head. That's 720. This one, 12p3. Gosh, you could just put this in your calculator, but you know what? This looks a whole lot like this. It's saying take 12 factorial, start writing 12 factorial, and just do the first 1, 2, 3 elements of that. The first 3 numbers are 12 times 11 times 10. I don't care to do that without a calculator. Okay, I got a new calculator here, so 12, it's a lot faster than the other one, times 11 times 10 is 1320. And you notice, also, you could have just as easily done, whoops, you could have easily done 12 NPR, oh, there's no screen press history. Maybe I should do this on the other one. Anyway, 1320, let's go back to here. Yeah, okay. All right, for part A, when they use the word permutations, they're meaning factorial, basically. They're meaning, or NPR. And when they don't tell you to take a subgroup, they mean do the whole thing. There's 1, 2, 3, 4, 5, 7 letters here, so that's all we have to do. It's basically how many ways can you rearrange the letters of the word Tuesday. It means if I'm not putting letters back, how many different ways can I draw one, and then draw another one, and then draw another one, and etc. I've got 7 choices for the first thing. I've got 6 choices for the next thing, etc., 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 without replacement. So it's like having these 7 Scrabble tiles. None of them match, so we don't have to worry about repeat letters and that kind of stuff. So that's great. There are 5,040 ways to do that. How many of them begin with A and end with Y? Well, if you're 7 choices you have to make, 4, 5, 6, 7. I've got, if this one has to be A, there's only 1 choice for that. This one has to be Y, there's only 1 choice for that. And if you think about it, at that point, I just have these letters I can actually, I actually have these letters I can choose from, because the A has been placed and the Y has been placed here and here. I've got those other 5 letters that have to go in there. So that's going to be 5 choices for this, because it could be a T, a U, a E, S, or a D. After I've done that, there's only 4 letters left, and then 3, and then 2, and then 1. So this is really like saying 5 factorial, which is like saying 120. Really what they're asking on this one, this is like that one you had in your quiz. Think about the different pairs of events here. And I think, yeah, A and B happening together, A and C happening together, or B and C happening together. Which two, are there any sets of these pairs of events here that are independent? Now, the one on the quiz was about being mutually exclusive. Independent is kind of like asking, are they multipliable? If you took one and then multiplied it by the other, would that be an appropriate thing to do? Like one thing and then the other thing happening following that. Okay, if A is the event that the number of heads is even, and B is the event that the first toss is a tail, are those things independent? Well, I don't really think so, actually, because if the first one, sorry, the event that the number of heads is even, remember the sample space here is we're tossing 2 coins here. So we have this one, we have heads, tails, we have tails, heads, and we have tails, tails. The number of heads being even, I mean, number of heads could be 2 or 1 or 0. Number of heads being even is either going to be this case or this case. The event that the first toss is a tail, well, that sort of affects whether or not the number of heads is going to be even or not. If the first heads is, if the first toss is a tail, I could either have 1 or 0. If the first toss could have been a head, it could have been 2 or 1 or 0. I think those are going to be independent. So let's say A and B are independent. A and C, A is the event the first toss is even, so that would be a successful, to A would be one of these two. And does that have anything to do with, is the event that the number of heads is odd? That would really kind of be the same. I mean, these things are mutually exclusive, right? So are they independent? Well, if I was trying to figure out the event that the number of heads is even and the event that the number of heads is odd, that seems kind of silly to multiply those because they can't both happen at the same time. The multiplication of that should be 0. And neither one of those is 0 on its own, so multiplying those wouldn't make sense because it would be non-zero. Okay, so oh wait, I said these were independent, didn't I? I just thought of that. Okay, sorry about that, kids. A and B are not independent. It's like too many negatives. Not independent. They are dependent. The number of heads being even. Like if I was gonna flip these two coins, and you were trying to bet on the first toss being a tail, and you wanted to know if the number of heads is gonna be even. If I said, okay, I've flipped two coins behind this curtain, and now you know one is a tail. Is that going to change your bet on A? Is it going to change whether or not you think the number of heads is even or odd? Well, it might. Okay, and that would be appropriate. C is the event that the number of heads is odd. I'm looking at this one now. Independent from the event that the first toss is a tail. I think all these questions are really the same thing. Are any of these events independent? I don't think any of these events are independent. I may go back and check the answer key on that, but I am thinking, well, comparing A and B and comparing C and B is really the same thing. The only thing that's sort of different in all of these is A and C, and that's the one where they're really mutually exclusive. So are they independent? I don't think so, because if I want to if I was going to multiply those two things, I would want it to be 0, and I can't multiply these two non-zero possibilities and get 0. Okay, we had a lot of this in the do now from last class. This means we're going to take the first 5 numbers of n factorial, so it's going to be something like n times the next one times the next one. These are decreasing whole positive numbers that we're trying to multiply together. That's a minus. I want the first 5. 1, 2, 3, 4, so the last one's right here. This is actually not that big. These get a little bit more theoretical when you've got a whole lot more to write. And then the first 3 of it, n minus 1 times n minus 2. Now if you were to expand this would be some nasty cubic polynomial. Who cares? I know this is a whole bunch of multiplication. This is a whole bunch of multiplication. I can divide both sides by n. I can divide both sides by n minus 1. Because I'm sure that's not 0, right? I mean, n has to be, from the beginning here, if we're going to say np5 in any case, you know that n is a natural number and it has to be greater than or equal to 5. I mean, you just know that from the start. Like that's you can't even say this without having that. So dividing these off is no problem, because you could say, oh wait, you can't just divide by n minus 2 on both sides. That's crazy. What if n is 0? This is a problem. Blah. Or what if n minus 2 is 0? What if n is 2? N is never going to be 2 if you're even talking about np5. All right, so everything's been canceled off here. All I have left is that 30, just sort of the difference that I'm being told here between np3 and np5, the fourth and fifth things that I multiply, which are these, multiply to make 30. So at this point, yeah, I've got a quadratic. If you really wanted to expand this, you could do this binomial expansion and get n squared minus 7n plus 12 equals 30, but that's a big mess because I already know that these are numbers like 100 times 99 times 98 times 97 times 96 or something like that. These two numbers are neighbors on the number line, and so really I'm looking for neighborly factors here that have a factor of 30 or have a product of 30. Well, you should go looking at the factors of 30, and there's not too many of them that are neighbors. 1 times 2, okay, it's not 1 and 2. It's 1 times 30 anyway, and 2 times 15, and 3 times 10. Oh, there's a lot of neighbor factors. Look at that. And 5 times 6. Oop, got it. 5 and 6. There you go. 5 and 6. 5 times 6 makes 30. So one of these is 6 and one of these is 5. And those are the two neighbor factors. Okay, great. So what does that mean? Well, I know n minus 3 has to be 6 and n minus 4 has to be 5. Either one of those you solve, you get the same thing. If n minus 3 is 6, then n better be 9. And you could check that. I would advise checking this because there's a couple guessy kind of